Okay, so we're going to look at classification of matter. So matter is anything that occupies space and has mass. I think you've probably heard this multiple times. So your textbook, your desk, your chair, your body, they're all composed of matter. You can classify matter according to its state or by its composition. So by state, I mean its physical form. Is it a solid, liquid, gas? Composition, is it a compound? Is it an element? Is it a homogeneous mixture? So that's what I mean by composition. So states of matter. So I know you've all heard this before and everybody knows it. So matter can be classified as solid, liquid, or gas. So I know you've seen this before again. So solid is a fixed volume and rigid shape. So examples, ice, aluminum, diamond. Liquid matter has fixed volume but not fixed shape, and it assumes the shape of its container. So examples, water, alcohol, gas, and I know you all know this. Gaseous matter. The gaseous molecules are free to move relative to each other, and there's lots of space within the gaseous matter. So there are a couple of molecules and there's lots of space in between. So that makes the gases compressible. So gases have no fixed volume and shape. So if you had a solid and you try to compress it, you're not going to get very far. On the other hand, if you try to compress a gas, you would be able to change the volume, you'd be able to change the shape, and it would be highly compressible. So if you try to classify matter by components, you get this. So when you're talking about matter, you can say element, compound, heterogeneous mixture, homogeneous mixture, and so on like that. But let's look at this. So everything that's physical, it has matter. So anything that is physically visible is matter. So if the matter has variable composition, meaning that depending on how much you mix in with it, you get different ratios of things. So for instance, if you have sugar water, you can have very, very sweet sugar water, or you can have really dilute sugar water that it's practically just plain water. So that would be variable composition. So if matter does not have variable composition, no, then it's a pure substance. If it does have variable composition, yes, then it's a mixture. Now, among pure substances, you can have two different variations. If the pure substance can be separated into a simpler substance, it's different than if you can't. If it is not separable into simpler substances, no, then it's an element. Excuse me. So the example of the element that's given here is the Goodyear blimp that has in it helium. So here is the element symbol for helium. So helium is one of the elements in the periodic table. So if you look at the periodic table chart, you will see helium. So it is just the single element helium. It's the element all by itself. There's nothing else in there. And helium cannot be separated into simpler substances. Now, true, you can probably separate helium into its protons, electrons, neutrons, but it cannot be separated into a smaller, different element. Okay, so the question is, separable into simpler substances, and you say yes, then it is a compound. So the example given for a compound is pure water. And of course, I know that you all know the chemical formula for water. So you have H2O. So our compound actually has, oops, I didn't mean to draw that line. But anyway, here's H2O. So this actually has two different elements in it. So you can separate it into simpler substances. It can be decomposed to the hydrogen element and to the oxygen element. So it actually has two different elements combined together to make the compound water. So it is a compound. Alright, so going back to variable composition, we said if it has variable composition, then it is a mixture. So we look at the mixture and we say, is it uniform throughout? So you have a glass of something and then you look at the different parts of it and you ask yourself, is it the same no matter where you sample the mixture? If the answer is no, then it is a heterogeneous mixture. So an example of a heterogeneous mixture would be wet sand. So if you get a glass of wet sand, so maybe at the very top of the wet sand, it would be more water. At the very bottom of the wet sand, it might be more sand. So anyways, anywhere along that glass of wet sand, if you sampled it at different positions, you would actually have a different ratio of sand to water. Okay, so that is a heterogeneous mixture. So to the question, is it uniform throughout? If the answer is yes, then it is a homogeneous mixture. So here's an example of a homogeneous mixture. So let's say we have tea mixed with water. So in your tea mixed with sugar. So in your tea mixed with sugar, you have tea, you have sugar, you've got water, and unless you're very lazy, you would have stirred it. So anywhere in that cup of tea, no matter where you went, you would have essentially the same ratio of tea to sugar to water. It would be homogeneous throughout. So that is a homogeneous mixture. So let's look at physical and chemical changes. So what's a physical change? A physical change is changes that alter only the state or the appearance of a substance, but not the composition. This is a physical change. So when you do a physical change, you don't actually change the atoms or molecules that make up the substance. You don't do any kind of chemical reaction. You just leave those atoms and molecules alone, and all you do is you just change the state of whatever you've got. So, for instance, an example of a physical change is when water boils. So, when water boils, you go from liquid water to gaseous form of water. It's still water. It's still H2O. The only difference is that it has changed its physical state. So here is our water, our liquid water. It still has the molecule H2O, liquid, and then you boil it. It looks different because now it's turned to steam. It's actually a gaseous form of water, so it's changed its physical state, but it still has two hydrogens attached to an oxygen, so the chemical composition is still identical. So this is a physical change and not a chemical change. So what about a chemical change? A chemical change, you have to alter the composition of matter. You have to make chemical changes. You have to do a chemical reaction in order to do a chemical change. So when you do a chemical reaction, what happens? Well, the atoms rearrange, you get a different molecule, something chemical happens to change the identity of the substance. You get a different substance. So you might not think so, but the rusting of iron is a chemical change. So iron is just the element Fe, the iron element. The iron atoms are arranged like this in a nice little structure like that. So this is just regular old iron. When iron rusts, what actually happens is you actually get a reaction between iron, Fe, and oxygen, O2, so then you get iron oxide. So you get a mixture of iron and oxygen together, so this is actually called rust. So the structure of your iron oxide looks like this. So you still have your iron atoms in there, and now you got some oxygen atoms stuck in there together. So you now actually have a totally different substance. So this is a chemical reaction, this is a chemical change. So more examples of chemical and physical changes. So here we have dry ice subliming. So dry ice is the molecule CO2 solid. When dry ice sublimes, you get CO2 gas. So dry ice subliming is that thing that everybody uses, on the stage when there's fog all of a sudden or something like that. So what you're doing is you're changing carbon dioxide solid to carbon dioxide gas. This is a physical change. Why is that? Because you still have CO2 down here, you still have CO2 up here. The only difference is you've just changed the state of matter from solid to gas. So this is a physical change. Now what about if you dissolve sugar in water? So you got sugar solid, and then you have sugar aqueous. Aqueous just means that you've dissolved whatever substance you've got in water. This is a physical change. Why is this a physical change? Because your solid sugar still has that same chemical formula as your dissolved sugar. The only difference is here I've got a little S in parentheses for solid. Here I've got a little AQ in parentheses for it's dissolved in water. So you haven't really done anything to chemically change the sugar. All you've done is you have dissolved it. Physical change. Okay, what about if you burn propane? Propane has chemical structure C3H8 and it is a gas. So when you burn propane, what you actually do is you do a reaction between propane and oxygen. The product that you get out is carbon dioxide and water. This is a chemical change. Why is it a chemical change? Because you start out with C3H8, you end up with CO2 and H2O. This is not chemically the same as the propane. It has completely changed. You've rearranged atoms around. You've made a different molecule. The identity of your substance has been changed. So this is a chemical change.